The AR-15 is a lightweight magazine-fed, semi-automatic rifle whose operation is based on a gas-operated system that uses energy from a fired cartridge to cycle the action. Its overall design reflects a balance between mechanical efficiency, controllability, and modularity. Developed from concepts pioneered by Eugene Stoner in the mid-20th century, the rifle departs from many earlier designs by emphasizing straight-line geometry between the barrel, bolt, and stock. This alignment helps manage recoil forces by directing them rearward rather than upward, which reduces muzzle rise and allows the shooter to maintain better control during repeated firing. To understand how the AR-15 functions, it is useful to examine its major components and then follow the firing cycle from the moment the trigger is pulled to the point where the rifle is ready to fire again. The rifle is divided into two primary assemblies known as the upper receiver and the lower receiver. These two halves are joined by takedown pins, allowing the rifle to be separated for maintenance or inspection. The upper receiver contains the barrel, the bolt carrier group, and the gas system, all of which are responsible for chambering rounds, firing them, and cycling the action. The lower receiver houses the fire control components, including the trigger, hammer, and safety selector, as well as the magazine well and the buffer system. Although these two receivers are distinct, their interaction is tightly synchronized, with each shot setting off a chain of mechanical events that passes energy from the upper assembly into the lower and back again. One of the most important parts of the AR-15 is the bolt carrier group. This assembly includes the bolt itself, the carrier, the firing pin, the cam pin, and related components. The bolt has several locking lugs arranged around its circumference. These lugs engage corresponding recesses in the barrel extension, creating a strong lockup that can safely contain the high pressures generated when a cartridge is fired. The carrier surrounds the bolt and provides mass and momentum during cycling. Inside the carrier runs the firing pin, which is struck by the hammer to ignite the cartridge primer. The cam pin passes through the bolt and rides in a curved cam slot in the carrier, translating linear motion into rotational movement that locks and unlocks the bolt during operation. The barrel is another critical component, serving not only as the pathway for the bullet, but also as part of the gas system. Inside the barrel are spiral grooves, known as rifling, which impart spin to the bullet as it travels forward. This spin stabilizes the projectile in flight, improving accuracy. Near the front portion of the barrel is a small hole called the gas port. When a cartridge is fired, a portion of the high-pressure gas, generated by the burning propellant, is diverted through this port. The location and size of the gas port are carefully chosen to ensure reliable cycling without excessive stress on the system. Attached to the barrel of the gas port is the gas block, which captures the escaping gas and directs it into a narrow gas tube. This tube runs rearward above the barrel and leads directly into the upper receiver, where it interfaces with the gas key mounted on top of the bolt carrier. Unlike designs that use a separate piston, the AR-15 channels gas directly into the carrier itself. This approach reduces the number of moving parts and keeps the system relatively light, though it also means that heat and fouling are introduced into the receiver during firing. At the rear of the lower receiver is the buffer system, housed within the stock. This system consists of a buffer and a recoil spring. Its role is to absorb the rearward energy of the bolt carrier group as it moves backward, slow and stop that movement, and then push the carrier forward again to chamber the next round. The buffer system is essential for smooth operation, as it moderates the speed of the moving parts and helps ensure consistent cycling. When the rifle is loaded and the safety selector is set to the firing position, Pulling the trigger begins the firing sequence. The trigger rotates on its pin, releasing the hammer, which is under spring tension. The hammer swings forward and strikes the rear of the firing pin. The firing pin, driven by this impact, moves through the bolt and strikes the primer of the chambered cartridge. The primer ignites the propellant powder inside the cartridge case, producing rapidly expanding gases. These gases push the bullet forward through the barrel while simultaneously pressing outward against the walls of the chamber and the face of the bolt. As the bullet travels down the barrel, it passes the gas port. At that moment, some of the high-pressure gas is diverted through the port into the gas block and then into the gas tube. This gas flows rearward and enters the gas key on the bolt carrier. From there, it is directed into an expansion chamber formed between the bolt and the carrier. The pressure of the gas forces the carrier rearward while pushing the bolt slightly forward. Because the bolt is locked into the barrel extension, it cannot move straight back at first. Instead, the cam pin riding in the cam slot causes the bolt to rotate. This rotation unlocks the bolt lugs from the barrel extension, allowing the entire bolt carrier group to begin moving rearward as a unit. Once unlocked, the rearward movement of the bolt carrier group performs several tasks in quick succession. The extractor, a claw-like component on the bolt, grips the rim of the spent cartridge case and pulls it from the chamber. As the case clears the chamber, it contacts the ejector, a spring-loaded plunger in the bolt face. The ejector pushes the case sideways, causing it to pivot out through the ejection port on the side of the upper receiver. Meanwhile, the rearward moving carrier compresses the buffer spring in the stock, storing energy that will be used for the forward return. During this rearward travel, excess gas that entered the carrier is vented through small exhaust ports on the side of the bolt carrier. This venting reduces pressure within the system and prevents damage or excessive recoil. At the same time, the hammer is forced back down by the carrier's movement. As the hammer is pushed rearward, it is caught by the disconnector if the trigger is still held back. This mechanism is what ensures that the rifle fires only one shot per trigger pull in semi-automatic configuration. When the bolt carrier group reaches the end of its rearward travel, the compressed buffer spring begins to expand, pushing the carrier forward again. As the carrier moves forward, the bolt strips a fresh cartridge from the top of the magazine. The magazine spring lifts the next round into position, and the forward motion of the bolt pushes it into the chamber. As the cartridge is fully seated, the cam pin again follows the cam slot, rotating the bolt in the opposite direction to lock the lugs into the barrel extension. This locking action ensures that the bolt is fully secured before the rifle can fire again. If the magazine is empty, a different outcome occurs. As the last round is fired and ejected, the magazine follower rises to the top of the magazine body and engages the bolt catch. When the bolt carrier group moves rearward, the bolt catch is pushed upward and locks the carrier in its rearward position. This open bolt condition signals that the magazine is empty and allows for faster reloading. Releasing the bolt catch after inserting a new magazine allows the carrier to move forward and chamber a fresh round. The trigger mechanism also resets during this process. When the shooter releases the trigger after a shot, the disconnector releases the hammer, allowing it to be caught by the trigger sear. This reset prepares the fire control system for the next shot. Each subsequent trigger pull repeats the entire cycle, from ignition to ejection to chambering. The gas system itself can vary in length depending on the barrel configuration. Rifles with longer barrels typically use longer gas systems, while shorter barrels use shorter gas systems. The length of the gas system affects the timing and pressure of the gas reaching the bolt carrier, which in turn influences the speed and smoothness of the cycling action. Designers adjust these parameters to balance reliability, recoil impulse, and component wear. Several additional features contribute to the rifle's functionality and safety. The safety selector blocks the trigger mechanism when engaged, preventing the hammer from being released. The forward assist, found on many models, allows manual pressure to be applied to the bolt carrier to ensure that it is fully seated in the forward position. While not always necessary, it provides an extra measure of assurance in certain conditions. The dust cover protects the ejection port from debris when the rifle is not in use and automatically opens when the bolt carrier moves rip. Overall, the AR-15 operates through a carefully timed interaction of gas pressure, mechanical movement, and spring forces. Each component plays a specific role, and small changes in design can have noticeable effects on performance. The layout, direct gas operation, and modular construction distinguish it from many other rifles and explain both its widespread adoption and its adaptability to different configurations. By tracing the flow of energy from the fired cartridge through the gas system, bolt carrier group, and buffer assembly, one can see how the rifle efficiently converts explosive force into a controlled, repeatable cycle that readies the weapon for the next shot. ChatGPT can make Mr.